A computer use agent doesn't plug into your apps. It sees a screenshot of your screen and moves the mouse, exactly like a person would. Start with what the agent actually gets. Not your files, not your window handles, just an image. A flat picture of whatever is on the display, the same pixels your eyes would see. Here's our running task. Click the save button, then type a fill name. Simple for you. But Claude can't touch your mouse. It only has that image. So how does a picture become a click? It doesn't click. It describes a click. Claude looks at the image and answers with an instruction: perform a left click at this exact pixel. This is the heart of it. Claude turns the idea, the save button, into two numbers, a horizontal and a vertical pixel position inside the image it was shown. A described target becomes an exact point. But nothing has moved yet. Claude only asked. Anthropic runs none of this. Your application is the one that has to make the click happen. That request arrives as a tool use response. The model stops and hands you a block that says, here's the action I want, now go do it. Now, the loop. You execute the action. You grab a fresh screenshot. You send that new image back. Claude looks again and decides, act once more, or I'm done. That cycle repeats, no human in between, until the task finishes. Remember, every turn it gets a new picture. So after clicking save, the next screenshot shows whether the dialog actually opened. Claude checks its own work before moving on. So what does your code do with a left click at a pixel? It fires a real operating system event. In the reference build, that's xdotool. Move the mouse to those coordinates, press the button. And the fresh screenshot? Captured by a desktop utility, GNOME screenshot. If it's there, scroll as a fallback. Whatever it grabs is literally what Claude sees that turn. To turn all this on, you add one tool to your API request. You give it a type, the display width and height in pixels, and flip on a beta header. That's the whole setup. Notice what you did not do: define the actions. Unlike a normal tool, you give no input schema. The list of moves is baked into the model itself, and you can't change it. That built-in vocabulary is small. The basics: take a screenshot, left-click, type text, press a key, move the mouse. Newer versions add scrolling, dragging, right and double clicks, and a wait. Typing isn't one-paced. Your fill name goes in keystroke by keystroke. The reference splits text into chunks of 50 characters and taps each key 12 milliseconds apart, so apps register every letter. Now a subtlety that trips people up. Your real screen might be huge. Before the image ever reaches Claude, it's shrunk down to a standard size, something like 1024 by 768. So Claude answers in the shrunk image's coordinates, not your monitors. Before you click for real, you have to scale those numbers back up. Divide by the same factor you shrank by, and the point lands where Claude meant. Get that size right. The doc suggests around 1024 by 768 or 580 by 720 as a solid baseline. Go too high, above 180p, or too low, and clicks start missing. Bad accuracy usually means the resolution's wrong. Where does all this live? Not on your actual desktop, usually. It runs in a sandbox, a virtual display, a lightweight window manager, a few pre-installed apps, all inside a container Claude can poke at safely. Two things sharpen it. Tell Claude to screenshot after every step and confirm the result before continuing. And the newest tool adds a zoom action so it can inspect tiny buttons at full resolution. So, a screenshot in, a pixel coordinate out, scale back and tick by your code, then a fresh screenshot, looping until it's done. That's how it clicks around your screen.